Hello, in this video we're going to continue talking about functions and function notation. This is section 3.1 part 2. In this video we're going to focus on determining whether a function is one-to-one, using the vertical line test to identify functions, and graph the functions listed in the library of functions. All right, so we're going to start talking about one-to-one functions. So a one-to-one function is a function in which each output value corresponds to exactly one input. That sounds really similar to what a function was. Remember, for a function, each input corresponded to exactly one output. In this case, we're saying a one-to-one function obviously has to satisfy that condition of being a function. Each input corresponds to exactly one output, but to be one-to-one, the function also has to have each output corresponds to only one input. So there are no repeated x's or y's in a one-to-one function. So let's first talk about some real-world scenarios. Is a balance a function of a bank account number? Is a bank account number a function of a balance? And then we want to know if a balance is a one-to-one function of the bank account number. So first we're asking about functions, then we're asking if it is a function, is it one-to-one? So I just want to remind you that an output is the function of input. The output variable is a function of the input variable. So when they say, is balance a function of the bank account number, what they're saying here is they're saying that the balance is the output and the bank account number is the input. So for this one, is a balance a function of the bank account number? The answer is yes, because each bank account has a single balance at any given time. So let's say you have bank account number and then you have the balance, because account number is the input and then balance is the output. So let's say you have bank account number 123, and then you have bank account number 124 and the bank account number 125. Well, account number 123 is going to have some balance. Let's say it's $5, and let's say bank account balance of 124 is $5, and the bank account balance of 125 is $10. Well, it doesn't matter that these are the same. It just matters that account number 123 has one specific balance. Now, yes, it changes over time, but at any given time, it has one balance. There's not two different balances in one account. Account number 124 has one balance at any given time. So, is this a function? Yes. Now, it also asks, is the bank account number a function of the balance? So this time we're going to reverse. We're going to reverse this. We're going to say balance and then account number. Well, in this case, let's say we have the 123 and the 124 accounts. Those both had, I said they both had $5 in it. So in this case, 5 corresponds to two different output variables. So two different account numbers. So because several bank account numbers may have the same balance, this means that this is not a function. And because you can't switch them up and then both be functions, meaning you can't switch the balance is a function of the bank account and the bank account number is a function of the balance. You can't switch those and then both be functions. It's not one-to-one. It's not one-to-one because, remember, to be one-to-one, each output value corresponds to exactly one input. So output value is balance, a one-to-one function of the bank account number. So again, we're looking at it like this, where the balance is the output. We have multiple outputs we have one output that could be multiple bank account numbers. So the answer here is no. So you guys try the next one. It's a try it, which means you're going to pause the video. You're going to read through these. You're going to try to answer the questions, and then you'll unpause it and we'll go over it. So go ahead and hit pause now. Okay, so you've unpaused, and the letter A says, if each percent grade earned in a course translates to one letter grade, is the letter grade a function of the percent? So is the letter grade a function of the percent? So here is our output, here is our input. So we have the percent is the input and the letter grade is the output. So just think about it this way. What letter grade is an 81? In our class, an 81 is a B. What about an 89? An 89 is a B. What about a 90? A 90 is an A. What about a 93? That's also an A. So in this case, an 81 is always a B. An 81 can't be a B and an A. It can only be a B. A 93 can only be an A. There's no percentage grade that's going to give you two different letter grades. So what that means is yes, it is a function. If so, for part B, is the function one-to-one? So basically, you want to go the other way. Can each output variable can only correspond to one input variable? So here, check out the B. A B could be an 81, it could be an 89, it could be an 80, it could be an 83, it could be any number between 80 and 89. So each output variable in this case corresponds to multiple input variables, so that means it is not one-to-one. All right, moving on. There's something called the vertical line test. So in the previous section, part one, same section, but part one, we talked about how to tell if a relation given as a set of ordered pairs or given as a table or given as a mapping was a function. So now we're going to look at graphs, and we're going to determine if those graphs represent functions or not. And in order to do that, we use what is called the vertical line test. So so given a graph, use the vertical line test to determine if the graph represents a function. So to do this, inspect the graph to see if any vertical line drawn would intersect the curve more than once. Now we use the word curve, but it could mean a straight line. So what that means is if you could draw a vertical line anywhere through your graph, and if it crosses the graph in more than one spot, then it is not a function. So if there's a vertical line that could potentially cross through multiple places on your curve or on the graph of your function, or your relation rather, then it is not a function if it crosses more than once. So you can draw the line. So you have to imagine like lines drawn, everywhere. So looking at this first one, you see that it's a function, but let me just show you why. No matter where I would draw a vertical line, in this case we drew it here, but it could be, you could draw a vertical line anywhere, and no matter where you draw it, it only ever crosses the graph once. Now when I say the graph, or in this case the curve, we don't mean the coordinate plane itself, but the actual graph of the relation. So it only crosses at most once, no matter where you draw the vertical line. So this one is a function. This one, you see they drew the line here, the vertical line here, and it crosses here. And it also crosses here. So it's because it crossed more than once, that means that this x value, let's see, 1, 2, 3. The x value of 3 corresponds to 3 and also to, looks like negative 2.5-ish. So, and this is actually not quite 3, but that doesn't matter. The point is 3 corresponds to this y and to this y. So because it corresponds to both, it can't be a function. Now you could draw a vertical line right here and come to the same conclusion, because this vertical line that I'm drawing, this imaginary one, it crosses here and here. Same thing here. All right, the third one is also not a function, because no matter where you draw a vertical line, it's going to cross that graph more than once. So if a vertical line crosses a graph more than once, no matter where you draw it, and it's vertical, so it's going straight up and down, then it's not a function. All right, so we're going to apply the vertical line test here. So let's see, let's do pink. So no matter where I draw a vertical line, I'm just going to draw a whole bunch of different ones through here just to see. It only ever crosses once. So this one is a function. All right. All right, if I drew a vertical line there, that's okay, that's okay, that's okay. But check out this. This one crosses in more than one spot. So that is not a function. I just want to alert you real quick before I actually draw the lines through this one. So let me erase those real quick. And I forgot to write here that this was not a function. And let me just redraw those lines. I'll just draw one through both. Okay, so going back to this one here, there's this funny little line going through here, and depending on your background in graphing, you may not be aware of what this is. This is not part of the graph. This is basically showing that there is a gap between this part of the curve and this part of the curve. It's kind of like the two parts of the graph are separate, and there is a big section that the graph is not crossing. There's a big gap in the graph, if you will. So even though this looks like it's crossing both parts of the graph, it's actually not. So no matter where you draw a line on this graph, it's only going to cross once. So this one is also a function. All right, your turn. Try it time. So pause the video, and when we come back, we'll decide whether this figure represents a function or not. Okay, so you've unpaused the video. No matter where you could possibly draw your vertical line, is only ever gonna cross once. So you should have said that this is a function. All right, so now let's talk about the horizontal line test. We have the vertical line test tells us if something is a function. The horizontal line test tells us if something is a one-to-one function. So to be a one-to-one function, it has to pass the vertical line test and the horizontal line test. So basically, we inspect the graph again to see if any horizontal line would intersect the curve more than once, and if a line such as that exists, then it is not one-to-one. So consider these two graphs are either one of these one-to-one. So if I draw a horizontal line here, it looks okay. But if I draw it here, look at this. It crosses 1, 2, 3 times. So because of that, that is not 1 to 1. All right. So again, this little red dotted line is a gap in the graph. It's called an asymptote, but there's nothing there. So no matter where I draw this line, it is not going to cross the graph more than once. So this one is 1 to 1. All right, your turn. Try it. This one is not a function because it doesn't pass the vertical line test, but why don't you try to see if it is 1 to 1 and if it passes the horizontal line test. So pause the video and unpause it when you're ready to go over it. Okay, you've unpaused, and let me just draw one horizontal line, or somewhat horizontal line, and look, it crosses twice, so that means it's not 1 to 1. All right, so now we're going to talk about some basic functions and their graphs that we will talk about throughout this course. We have your basic constant. A constant is a function where it's just a number, such as, let's say, f of x equals, let's say, 2, since that's what's graphed over here. So there's no variables, there's just a number. And so if you'll look over here, if you can see this graph, no matter what I plug in for x, -2, 0, 2, if I plug in 3, 5, 8, no matter what, the y or the f of x is going to be 2. So that graph looks like a horizontal line. So a constant is always a horizontal line if a function is a constant. Then, so these are the names of the functions, the function names. The identity function, f of x equals x. So this is no matter what you plug in for the x, you're going to get the same exact number for the y or for the f of x. So you have the point -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, and it forms a slanted line that has a slope of 1, goes through 0, 0, looks like that. All right, next we have absolute value. Absolute value is the distance a number is from 0. So when you put a number in the absolute value, so like if I said the absolute value of 2, that means that how far is 2 from 0 on the number line? It's 2 spaces. But if I said what's the absolute value of -2, -2 is also 2 spaces. So when you find the absolute value, it's always positive because it represents a distance. So in this case, you have the absolute value of -2 is 2. The absolute value of 0 is 0 because 0 is 0 spaces from itself. The absolute value of 2 is 2. So we've got the point 0, 0, 2, 2, -2 up 2. You have the points 1, 1, and -1, 1. Anyway, it makes a V. So absolute value functions always make V's. All right, then we have one of my favorites, a quadratic. I talked about this, I think, in the, part 1 video. So this is, if you can see it, these look a little blurry. F of x equals x squared. So when you square a number, you multiply it times itself. So I've plugged in the numbers -2, -1, 0, 1, and 2. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So if I plot those points, -2 up 4, -1 up 1, 0, 0, 1, 1, and 2, 1, 2, 3, oops, 4. And I didn't count right for my -2 up 1, 2, 3, 4. There we go. And so that makes a parabola, and I didn't draw that well. Let me try that again. It's kind of like a curvy U, but the sides of the U are kind of going out instead of straight up. They're going out and up. In this case, out and up. Parabolas can also be facing down like that. So far we have a constant, which looks like this. Identity looks like that. Absolute value is a V, and quadratic is a parabola. Parabola. All right, so there are more. So next we have a cubic. A cubic is, again, I'm not sure if you can see this, when you cube your variable. So if you look, we've got the numbers -1, -0.5, 0, 0.5, and 1 that we plugged in. If you cube -1, -1 to the third is -1. So that's the point. -1, -1. If we cube -0.5 or -1/2, you get -1/8. So that's the -1/2 and then down 1/8. So that's like really close to the x-axis there. So you can kind of see where they have that point. And then 0 cubed is 0. 0.5 or 1/2 cubed is 1/8 or 0.125. And then 1 cubed is 1. And that was a little. And then if I cube 2, 2 cubed would be 8. And if I cube -2, that'd be -8. And so it makes this kind of a wave. It looks like that. Something like, let me draw it one more time. There we go, like that. That's a cubic. All right, then we have the reciprocal. This is one of those where it has like the gap in between. So we have some negative points, we've got some positive points. -2, -1, -1/2. So -2, if you put 1 over -2, you get the point -1/2. So if you go over to the left, -2, down 1/2. If I put in -1, 1 divided by -1, we're doing 1 over x, by the way, I don't think I said that, you get -1. So -1, -1. If I plug in -1/2, -0.5, you get 1 divided by -1/2 is the same as -2. So you have the point -1/2 down 2. And so you keep going, and what happens is you'll see that the closer you get to 0, the further down it goes. But if I put in 0, look what happens. 1 divided by 0, that gives you an error because you can't divide by 0. So that's where that gap comes in, right here. There's not going to be any points there because you can't plug in 0. That's where there's kind of like a hole in the graph. So then when you go to the positive side of that big gap, that is called an asymptote. 0.5, 1 over 0.5 is 2, so go over 1/2 and up 2. 1 over 1 is 1, so 1, 1, and then 2 makes it 1/2. And so what this does is it makes a curve on either side, like that. So this graph looks like something like that. And let me fix that a little bit because it looks like, there you go. Looks kind of like that. All right, and then this is called, going backwards real quick before I go to the next one. This one was f of x equals 1 over x, in case you couldn't see it. Now this last one is called reciprocal squared. So it's similar to the last one, except it's over 1 over x squared. So you square it before you divide by 1. So -2, 1 over -2 squared is the same as -1. When you square it, it becomes a positive 1/4 or 0.25. So if I go to the left 2, I go up 1/4. 1 over -1 squared, Negative 1 squared is 1. 1 over 1 is 1. So negative 1, 1. And then negative half, you'll get 4. And so you keep going, and you're going to go further and further and further up. But again, this is another one where you can't plug in 0. So there's this hole here. There's nothing that's going to cross the y-axis there. And so then the same thing happens on the other side. It's kind of like a mirror image, because when you square a negative, it's the same as squaring a positive. So the positive numbers are going to give you the same values. And it's very similar to the reciprocal, except everything is on the positive side. So this graph looks like that. All right. And we have a few more. 2 more, I believe. Yeah. So just to review so far, we've got the constant function, which is a horizontal line. Identity function is a diagonal line. Absolute value is a v. Quadratic is a parabola. Cubic is kind of like a parabola, but on one side it goes up, and on the other side it goes down. It's kind of what that one is, or the way I think about it anyway. Then your reciprocal, you've got a curve going up and a curve going down, and then reciprocal, you've got 2 curves like this. All right, so going to our last 2, you got the square root function and the cube root function. So square root function is just the square root of x. Now, what you'll notice about this is you can't have the square root of a negative number. So you can't do like the square root of negative 2. If you try to do that in the calculator, it's going to give you an error. We can only plug in positive numbers and 0. So I've got the numbers 0, 1, and 4. And we chose those because they all have nice square roots. So the square root of 0 is 0, so that's the 0.00. The square root of 1 is 1, so that's the 0.11. And then 4, the square root of 4 is 2, so 4, 2. And so it makes this curve. And it goes to the right, you can draw the arrow, but on the left-hand side you can't, because, again, there are no numbers on this side of the graph, because you can't have a square root of a negative number. Okay, so then, but you can't have a square root of a cubed. I'm sorry. Scratch what I just said. You can't have a square root of a negative number, but you can have a square root of I'm saying this wrong again. I'm going to pause for a second, collect my thoughts, and re-say it the correct way. Okay. You cannot have a square root of a negative number, but you can have a cube root of a negative number. There. Woo! I said it. It wasn't that hard, but it seemed so hard there for a second. I'm getting tongue-tied, saying the wrong things. Now you are wondering, should you have chosen me as your instructor? Yes, you should have, because I'm just showing you. I did that on purpose to show you that we all make mistakes, right? You believe that, right? Probably not, but that's okay. Okay, so the cube root function, so it looks like this, in case you can't see that font there. It looks like that. And you can take the cube root of a negative number and a positive number. So the cube root of -1 is -1. So that's why you have the point -1, -1. They did the cube root of -1/8 or -0.125, and you get -1/2. So -1/8, -1/2. 0, 0. And then 0.125 is 0.5. And then the cube root of 1 is 1. And so it's kind of like a sideways parabola, where it goes up and to the right and then down and to the left. It's kind of like a parabola that's sideways, right? Except you take this part here and you turn it to go this way instead. So now it looks like that. So it looks like this. Okay, so these are your basic functions when you graph them. We didn't add any extras. It's just basically you're doing that type of function to x. So the cube root of x, the square root of x, reciprocal is the reciprocal of x. Reciprocal squared would be the reciprocal of x squared. Cubic would be cubing x. Quadratic would be squaring x. Absolute value would be the absolute value of x. Identity is just x. And constant is the only one that doesn't really have an x, and that's where you have just a regular number, a regular constant. The point is, these are the basic functions. So what we're going to do in later sections is we will add to these functions, we'll add other numbers to this function here, and it's going to move the function, keep the same basic shape, but it will move it around. I'll move it to the left, move it to the right, move it up, move it down, make it wider, make it skinnier, that kind of thing. But we will talk about that in other sections. So just to recap, we talked about one-to-one functions, and a one-to-one function has to be where only one output value corresponds to only one input value. So kind of like the reverse of what we say a function is, but also what the rule for the function also has to be true for it to be a one-to-one function. So basically each x can only have one y, and each y can only have one x. And then we use the vertical line test. If we draw a vertical line anywhere through a graph, and if it crosses the graph more than once, then it's not a function. And same thing with the horizontal line test. The horizontal line test can tell us if something is not a one-to-one function. So if you draw a horizontal line anywhere through a function and it crosses that function in more than one spot, then it's not one-to-one. And then we talked about our basic functions and what those shapes were. Okay, so that is all for 3.1.